Okay, so we're going to review for the test for 2.1, 2.2, and 2.3. So the topics that are going to be covered on this, as you can see on the top of your review sheet, which I will pull up right now. Okay, 2.1, we talked about midpoints, perpendicular, bisect. We defined all of these things: segment bisector, angle bisector, perpendicular bisector, equidistant. In all of these cases, you should be able to mark diagrams, right, with given information. So let me go back to this. If you have midpoint, midpoint is always on a segment, and it's exactly the point in the middle. So if C is the midpoint of DF, let's say, you can mark these two congruent. You should always know how to mark them and then write a conclusion from them. So DC would be congruent to CF. All right, perpendicular. Right, the symbol is this, and it means intersects to form right angles. I'm not going to write everything out here, but right angles, so you should mark an angle congruent. As a right angle. The next one is bisect. That means you're cutting something exactly in half. We had two kinds of bisectors: segment bisectors and angle bisectors. If it's a segment bisector, it's going to go through right at the midpoint. Again, creating two congruent segments. If it's a segment bisector, you're marking segments congruent. If it's an angle bisector, and it's going to go straight through the center of the angle, creating two congruent angles. So if it's an angle bisector, you're marking angles congruent. Okay? And then perpendicular bisector, that actually combines two things. Bisects a segment at a 90-degree angle, cutting it in half. Okay, so two things: congruent segments and a right angle. Equidistant just means the same thing as congruent segments, right? If CF is congruent to CD, that means D is equidistant to C as F is equidistant to C. Okay, so they're the same distance. C is the same distance, equidistant from D and F. Okay, segment addition postulate. When you have one piece of a segment plus the other piece of the segment, it equals the whole segment. So this piece plus this piece equals the whole thing. And that you just have to be able to label and then write equations for. Okay. So this is all 2.1. Any questions from there? Any questions you want to ask about there? Writing equations. Okay. 2.2 might have been the more involved section. 2.2 had basically four concepts. You can see there's vocabulary there, but let's talk about the four concepts. First concept was the three angles of a triangle add up to 180. Triangle sum theorem. Right? Three angles add up to 180. I think we all are familiar with that. The second one was that if you have a exterior angle of a triangle, now this is the theorem everybody always wants to forget about, but let's call this angle 3. 4 is a linear pair with 3. So 4 is not involved in this theorem. This theorem is called the exterior angles theorem. And it says the measure of an exterior angle, so in this case the measure of angle 3, is equal to the sum of the two remote interior angles. So the two that are not forming a linear pair with it. That's the exterior angles theorem. Okay. The third one was the small side plus the medium side of a triangle are greater than the large side. And that always has to be true. If you add up small and medium and it's equal to large, then it's not a triangle. For small plus medium is less than large, that's not a triangle. The only way it works is if it's greater than the large side. Okay, and then we talked about small angle is across or opposite from the small side. And the medium angle is across from the medium side. And the large angle is across from the large side. Okay, so that's going to be putting either angles or sides in order. Any questions from that section? Your formative was on that. Make sure you go over your formative. Yeah. It's not really a theorem. It's more of a concept. It didn't really have a name. Okay. It won't be in a proof, really, that one. Okay. 2, 3. Isosceles triangle theorem, basically. That was the big concept. And that says if you know that two sides of a triangle congruent, then the angles opposite those sides are congruent. Converse of isosceles triangle theorem, just reversed that. If you know the angles are congruent, then you can conclude that the sides are congruent. So this will turn up in proofs. Know that isosceles triangle theorem is you already are given, or you somehow figure out that the sides are congruent, and you're concluding that the angles are congruent, and vice versa. The only other thing that was in here was equilateral triangles. Right? All three sides are congruent. That makes all three angles congruent, and it makes each angle equal.
Good afternoon. Will Jennifer Strohmeyer please report to the main office? Thank you.
Okay, that pretty much covers it. Of course, there's proofs. So, you know, we can go over anything that you have questions on proofs. Does anybody have questions on what I've said so far? All right, does anybody have questions in the review packet that you would like me to do up here? Thomas. 3? Okay, so draw and label this diagram. When it says draw and label the diagram, you need to read carefully and label the diagram. Remember, like the formative that I gave the 22s, where you had to have the diagram and mark them, you should be marking your own diagrams. Even though it doesn't say you have to, you should. Okay, so this says draw and label a diagram in which QS, so that's ray QS, bisects segment XY. So I'm going to start with XY. And if it bisects XY, what's going to happen to XY? What does bisect mean? Half, right? So if the segment is getting cut in half, what could I mark on that segment? They're going to be congruent segments, right? So if the QS goes through, it bisects it, that means it's going to go right through at the midpoint, which means I can mark this congruent to this. Does that make sense? Bisects means it cuts it in half. Mark them congruent. Okay, at point M, so the M is right here. All right, then we can label our diagram. If XM, that's here, is 2x plus 5, and XY, that's this whole thing, is 5x, how can I relate those two values? How can I write an equation for that? Yeah. Exactly. Okay, because of that word bisect, since it says that it bisects, if this one is 2x plus 5, that means this one is also 2x plus 5. And so our equation becomes this plus this equals that whole thing. Another way to write it would be 2 times the 2x plus 5 equals 5x. It comes out the same both ways. You can solve that now. Yep. Yep. Down here? Sure. Okay, so we switched all the way to the back now. We're doing the proof on the back. All right, so we are given that angle 1 is congruent to angle 2. I'm going to mark my diagram, angle 4, mark my diagram that way. I'm trying to prove that ABC is isosceles. What does it mean to be an isosceles triangle? Kevin. 2 sides congruent, right? So if my last step